Future features. All right, let's talk about IAM. Okay, so this service governs access to AWS. That's it. This is not a service that is for enabling your applications to have their own username and passwords. It's really just for governing AWS access. So we're going to talk a little bit about the shared responsibility model. We're going to talk in general about IAM and just the whole user authentication and authorization. Oh, that's right. And we do have a lab for this. That's right. We got this lab and we've got the S3 lab. So we'll do that actually after lunch. It'll be fun. Okay, here's the deal. The shared responsibility model is a concept that exists outside of AWS. Here's the general thought process. If you have physical access to the system, or you can log into the system, or you can configure the like portions of the system, you're responsible for everything you have access to. So for example, if someone comes to you and says, hey, who's responsible for securing physical access to AWS's data centers? And you're like, brother, I don't even know where those data centers are. Then guess what? You're not responsible for security of those data centers. You don't even know where they're at. Someone says, hey, who's responsible for securing that load balancer? Well, if you can't log into the load balancer because it's an AWS device, you're not responsible for securing it. Now, if you put a hole through configuration on that load balancer to where it talks to your layer 7 application, your web application, that's you. You're now responsible for that layer 7 traffic that flows through there. So if your application's like, woohoo, I'm going to go attack the government, right? That is going to be your responsibility. Okay. So that's what this says. This says that AWS is responsible for security of the physical cloud and stuff that you can't touch, but you're responsible for everything else. If you can configure it, you're responsible for it. If you can add encryption, you're responsible for encrypting your data. If you can add a layer 7 firewall to block your web traffic and get it filtered, you're responsible for turning that on. That's AWS's thing, okay? So be aware that if you can log into it, configure it, or you know physically where it's at, those are kind of like your litmus tests of how much responsibility you have for it. If you don't have those things, then you're not responsible for it. As a general rule of thumb, AWS is a security company first and foremost. How do we know? Because security was the #1 complaint about using any kind of cloud provider, and now they have more security certifications than most entities in the world, right? So, be aware that security is a #1 priority for AWS. Now, has a responsibility is that since you can configure access to your account, you're responsible for the security of your account from like a username, password kind of perspective. But everything else is going to be AWS's responsibility. All the global infrastructure, all the physical security. For example, if you start an RDS database and you can log into the database, then you are considered to own the security of that database. But you can't log into the operating system, so AWS is responsible for the operating system. Anything that's serverless, by the way, where it basically says that Amazon's hiding the servers from you, you are not responsible for patching those servers. AWS is. Let's see, Billy, is there a service that will store keys? Yes, it's called the KMS, the key management service, right? If so, would that be considered a responsibility or us responsibility? So you're responsible for rotating your keys. Amazon will generate the keys, obviously, for you at your request, but like rotating the keys and whatnot will be your responsibility. Storing them, especially if you store them with AWS, that's your responsibility. Now, if it's a client-side key, you own that client-side key, so you have to store it and take care of it yourself. It's a server-side key, which is what you're probably talking about. Amazon will securely store that for you. Now, if you need, for example, FIPS 140-2 compliance, which is a higher level of compliance, then you might go for Cloud HSM, although I just found out recently that now KMS also has FIPS 140-2 compliance, which I didn't even know that was possible with a software service, but whatever. Point being is that, yes, it's their responsibility to store the key securely. You're responsible for like rotating the key. So that KMS is used as a key service, sure. As far as like security responsibility, generally, no. Learning how to use like secure your applications is definitely a part of the developer exam. But you know, discerning the level of security responsibility, that's mainly on the security specialty exam and the SysOps exam if you're taking the systems operations exam. So mainly they're interested, do you know how to do application security? For example, do you know about vaults like parameter store? Do you know about secrets manager? Do you know when to use one versus the other? That kind of thing. Not like deep level security information. Don't worry, we'll cover that, Billy, to make sure you know exactly what domains are on the exam. Okay. Okay, I mentioned before that identity access manager, or identity access management really, offers like functions off of users, groups, and roles. Those are the principal identities. You have to attach permission policies, which I don't even know why they put those separate. You have to attach permissions policies to one of those three entities. General rule of thumb is that you're going to follow least privilege, which means you only give the person exactly what they need to do what they need to do. You don't give them more. And also that, you know, typically policies are attached to groups. The groups themselves are intuitively named. Users can belong to multiple groups. So roles tend to get named like groups are named. Like this is the full S3 access for Project B role, right? This is the security auditor role for accounts, you know, C9, 12, and 15. So typically policies are attached to groups, users are stuck into groups, right? So remember, roles are considered by Amazon to be used for temporary short-term access. So if someone's like, hey, you need to grant temporary access to an auditor who's going to blah, 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 blah. If the auditor has an AWS account, that's going to be a role. If the auditor doesn't have an AWS account, then you're going to have to give them a username because they still have to have a username to use a role, right? That kind of stuff could be on the exam. By the way, also to kind of set every one of these, you're going to get access to some of the best practice exams in the industry as part of taking this class. I'm going to cover that with you tomorrow. You're probably going to get an email from WebAid Solutions that grants you access to the developing on AWS practice exams. And we love these exams because they're approved by AWS and they will definitely help you pass. So you're going to get a feel for what's on the exam through these sets of practice exams that we're going to walk through on tomorrow and on Wednesday. Okay. So, by the way, these are the same exams that I use in conjunction with the guide that you're going to get to pass the certifications. And I passed some really difficult. I've passed 2 pro and specialty level certifications in the last month. Now, let's be aware, I've been working with AWS for 10 years, so hopefully I picked up a few things along the way, but we're going to set you up for success. So for those of you who are like, is this, you know, want to make sure that you're comfortable, you're going to be very comfortable with the exam and what you need to do by the time we hit the end of this class. Okay. So users, groups, and roles, policies are attached to these 3 entities. It's pretty straightforward. Now, how do you get started? Well, first of all, someone has to create the AWS account. That's usually called a root user. That user uses an email address to log in. You will never use that user past creating the initial administrator user. You should never use that user again. That's called the root user, and it cannot be restricted if the account was created prior to like December of 2018, 2017, one of those years. So just know that the first thing it's going to do is that you're going to get an IAM account user. That user is going to be made part of a group, which preferably has some kind of administrator permissions. And you might create roles if you want to grant, users, or services an elevated set of permissions. Notice that roles, I didn't say this before, is that roles can actually be used to make it so that an EC2 instance can talk to a DynamoDB database. You can use a role to make it so that a container running on ECS can talk to S3. And you definitely use it with Lambda. You can actually grant Lambda an execution role, sometimes called a run role, that will allow you to, that Lambda can talk to, Kinesis or RDS or S3 or a bunch of services. So just know that roles are not just used for users, they're also used for AWS services. So best practices is that when you want to grant an application running inside of AWS in any way, shape, or form permissions to another service, give the application environment a role. So if the application is running on EC2, give the EC2 instance a role. If the application is running on a container on ECS, give the ECS task a role. If it's running on Lambda, give the Lambda a role. Roles are the way to give your applications running on AWS access to other AWS services. And remember, all three of these entities, users, groups, and roles, have those policies attached to them. Now, let me rewind this so we can get some visuals on this. So I created an account. It's called itamazonian@gmail.com. And that's actually the username for my locked down demo account for AWS. First thing I did is I went and created a Spartan Sage user. That's an IAM user. It's not a root user. How do I know? Because it doesn't have an email address as the username. Email address is the username. That's a root user. No email address. That's an IAM user. There can be only one root user per account because that is the email address that was used to create the AWS account. That email account has to be unique, typically. It also usually has to have a phone number and a credit card associated with it. If you have not created one, I would highly recommend that you do so. Please, please, please do not use your bah.com email address to create a free AWS account. If you do that, it's not going to be catastrophic, but you're going to get a bunch of uncomfortable communications from security. And then your manager is as well. You're probably going to get a phone call. They're going to want to know what you created this for Booz Allen official context. They're going to want to know the billing code and all this other stuff. Just don't do that. Just use your own personal account. Yeah. Austin, I was trying to minimize that, but it's not a happy experience. I haven't experienced it personally, but I know people who have. So,
well, I have with Azure. I use my BA to create an Azure account, and exactly what you said, I was getting all kind of nasty emails and
yeah,
and so
yeah, yeah. And it's funny because I remember asking the security guys, I was like, why do you guys do that? And they're like, because they have contracts with Google, Azure, and AWS, and any account that is created that ends in a bah.com email address, they're financially responsible for. I was like, well, that's an interesting contract to sign, but okay, cool. Anyway, so that's why they're kind of draconian about it, is that they're financially responsible for it. I don't know. I don't remember what Booz's annual spend is with AWS, but what this guy Ratio was telling me one time that it was north of $40 million a year or something like that, easily north, but he didn't want to tell me exactly how much it was. I was like, 40 million, that sounds light. I bet you guys are probably in the couple $100 million range, right? Yeah.
So this account that you're speaking of here, is this when you initially log into AWS, get an AWS account?
Yeah. So when you go to create an AWS account, you have to use an email address.
Right.
But after that, for example, if we go look at mine, if I sign out of this, what will happen is that you have two options to log in. So if I want to log back in, I can either log in using the root user email address, or I can log in with an IAM user. This root user, by the way, there's only one of them per account. And this for me, for example, I think it would be IT Amazonian. I haven't logged in a while with this, so I'm not even sure this will work. But notice that it's asking me for a security challenge because it's like, what are you doing? And then what will happen is that, assuming again that password even works, which I don't even know if it does. Let's see. Oh, and it's got multi-factor, because it should, because everything should have multi-factor. I'm now logged in. If I log in as this, I'm now logged in as the owner, which by the way is going to send me a bunch of notifications saying, hey, you just logged in as the owner, because I have it set up to throw a fit if I log in as the owner. Where are you? So, so now I'm logged in as the owner. Now, notice, by the way, it's throwing the new console home. So notice that up here, I no longer have an @account number, because now it's like, nope, you are logged in as the account owner. I have no limits on my permissions, by the way, as this user. Accounts created after December 2018, you can actually use what's called organizations and put SCPs on here and limit this user. But this account, I think, was created in like 2013. So, and if I log back in as an IAM user, this is a user that exists inside the account. And notice that I'm not using actually a username, like an email address here. I'm using an IAM username. This only works if you specify the account ID or use a special URL that has the account ID in it. Notice that my account ID is an alias to M. Forrester. That is globally unique. Nobody else has an account name called M. Forrester. I'm the only one. Doesn't mean they don't have like M. Forrester 1 or something. So my point being is that this is now an IAM login, which is a user inside the account, but you have to know your account ID for this to work. If you don't know your account ID, you have to log in as the root user. And MFA for the win. Oh, hold on.
And you can add as many users under the real user as you wish, right?
Yeah, there's no limit as far as I'm aware of.
Okay, so it's
I'm sure there is one, but I think it's like 5,000 or something ridiculous.
So it's kind of like an organization then where the real user, the root user, is at the top, and you can filter down different users underneath that.
I'd be careful with the word organization, because that's an AWS service that manages multiple accounts. So
I'm just trying to do a visual construct of what.
Oh, yeah. Well, don't worry, we're about to see one. So here's the root account, right? Here's like, assume that's Spartan Sage, so that would be me. And I'm part of the admin group as an example. I am all inside of the organization of maria@email.com, right? So in that thinking, Gerald, you're totally right. This user is now inside of an organization, right? And this organization is the AWS account. But I want to be careful with that, Gerald, because I walked into, like, for example, Honeywell, they had 700 AWS accounts, and then I put them into what's called an AWS organization. And that allows you to manage multiple AWS accounts as if it's one account. So just want to make sure that's clear. All right, so I'm going to leave this up because we are at my plus or minus 5 minutes at noon. So you can see this. I'm going to go back over this again just to make sure that we're all in the same space. But if it's okay, I'm going to pause there. Does anyone have any burning questions before I close this out for lunch? Okay. I'm going to leave this up. I'm going to put up a timer. It's currently 12:05. So let's come back at 1:05 in 60 minutes. So take 60 minutes for lunch. I highly recommend, by the way, you get away from the computer if you possibly can. Otherwise, I'll see you in about 59 minutes and 50 seconds. Okay? We'll see you in about an hour. Have a good lunch. All right. Give me a thumbs up or some kind of response just to know that I know people are there. Sweet. Okay. Thank you. Thank you. Okay. So let's continue on with our discussion around kind of getting started with IAM. So kind of to review, we've got our root account, which we use to create our AWS account. And that comes with an account number, which of course you can alias to a name if you want to. And from there, if you want to log in with something other than the root account, you have to have a sign-in URL. Now, the sign-in URL, if we actually go look at the management console and go look at IAM in particular, you'll see that my sign-in URL right off the dashboard for IAM, my sign-in URL is right over here. And notice it's mforrester.signin.aws.amazon.com/console. That could be an account number .signin.aws. So the account number is the number that you see there. So the idea here is that once you log in with the root account, the first thing you do is you create an admin user. This is an IAM user. This user is now inside the IAM service. You'll now need that URL or the account name or number plus the username and password for this user to log into the console. Then you can actually stick the user into groups or other sub-users into groups that you create, and you can assign policies to users, groups, or potentially roles if you decide you want to use roles in your organization. Remember, the root account cannot really be restricted in any way, shape, or form. It is recommended that you do not use the root account for anything. I do know of at least one company in 2015 that was put out of business because they didn't secure their root account and someone came in and deleted their entire environment. So a reminder is that while permissions are assigned to groups, we do also create roles that can get permissions assigned to them. And those roles are temporary security identities that we can like be a part of, right? Take ownership of, become for a bit, right? So Maria can actually become the temp dev role. Mary can become the temp dev role. In other words, you can assume a role. Now, the way this works is that we have to basically authenticate first, meaning you log in with a username and password, preferably, by the way, with multi-factor enabled, as you've seen me log in several times, and I had to have the code. So two-factor means something you know, like a password, versus something you have in your possession, which contains the code, like a phone, for example, or a hardware key. And so once you get authenticated, then you are authorized to do something. In other words, once we know who you are, which is what authentication is, what are you authorized to do? Once we know who your user is, what can you do? Well, policies define that. And policies are explicitly allowing or explicitly denying, because just so you're aware, if you do not have a policy attached to your user or the group that your user is a part of, you have an implicit or invisible deny. You can't do anything by default in AWS unless someone gives you permissions to do so. That's the bottom line. So here we've got two different policies, and one grants full access to the bucket, and one grants only read-only access to the bucket. So as part of the principle of least privilege, you want to start with the minimum amount of privileges for what the user says they need to do, or hopefully someone has verified they need to do. And so part of this is that you want to start with permissions that are very lean, very granular, and then add to them as the, it's revealed that the user needs them. Be aware that if the user just needs temporary elevation, then granting them a role is probably a better idea instead of giving them permanent elevation of permissions. Here's an example IAM policy. So I know you've never seen this before, but first of all, is this an allow or a deny policy? Oh, sorry, Adam, I just saw your thing. Let me pause 1 second. Adam, there's some protection built in though, right? Because by default, you don't have access to anything until you add it. Yes. Yeah, that's what I mean. Implicit deny. In other words, any new user has no access to anything unless you actually explicitly grant them access. But if you don't give them anything, they got nothing. So by default, everyone is denied access to anything. Okay, so some of you said allow. Okay, so what service is this in relationship to, right? What service does this policy govern? What are we allowing them? What service are we allowing them to touch? So S3, good. Now here's the interesting thing. What specific S3 resources are they allowed to actually apply these actions to? What specific S3 resources? Well, that's the operation. So it looks like they're able to delete an object, and it looks like they're able to get an object, but what specific server resources are they able to touch? In this case, it's the billing marketing bucket and the billing sales bucket. So yeah. Now notice also that this one has a condition on it, which conditions are not required, by the way. This one says that they can only make this call against these resources if it comes from this network. Notice it's a network. It's a /24. It's not a /32. So it's a 10.14.8. Whatever, 1 through 255, right? Or 1 through 254. So specifically, anything in that network can be rolled in, can actually like execute these calls, delete object and get object. Now, I find this a little funny, just so you know, is that we are allowed to do anything to anything inside of these buckets, but we're actually messing with objects. We're not messing with the buckets. So objects are, by the way, the things inside the buckets, like a file, an image file, video file, that kind of thing. So by the way, if that policy said deny, no amount of allows would ever let that person do a delete object or get object against those buckets from that IP address. So just know, if this was a deny, denies have to be removed before allows can take hold. In terms of precedence, explicit denies will trump explicit allows, and both of those will trump the invisible deny that is the base of all AWS accounts. So without a policy, you can't do anything. If someone says you can do something, you can do it. If someone says you can't do something, you can never do that thing until that denial is removed. Okay. Now, we talked about ARNs before, because ARNs are unique resource names assigned to every single resource, every service, every object inside your account. Notice it's ARN : AWS : the service, the region, if it is a regional service, which a lot of them are, most of them are, the account, and then the resource ID, which could be an EC2 name, could be an S3 bucket name, whatever, right? Notice the DynamoDB example. DynamoDB US West 2 account name, and then table/accounts, which is all part of the resource ID. Notice that S3 is a global service that has regional home bases. And I know that's a little confusing, but it lives regionally, but it's managed globally. Notice that one doesn't have an account number. Honestly, usually it does. So I'm a little confused by that, frankly. It usually doesn't have a region name, though. They have made some changes over to ARNs over the years, but they've been slow to do that. Now, we have been mainly talking about permissions as it relates to users. You can also assign permissions to services and say, hey, in other words, there's two ways to get access to a service inside of AWS. You can go to the user and say, hey, user, you're allowed to touch this service, or you can go over to the service and you can say, these users are allowed to do this, and this to me, right? Two different methods. One is where you attach users to a service. The other one is where you attach services to a user. So that should make sense to you. The problem is that resource-based permissions are very rare. These are usually for services that predated IAM, like SQS, S3, that kind of thing. Let's see, when creating a policy for S3, is there a way to see all the different variables you can set? Yeah, Justin, you have to, they're in the documentation. You have to, or you can use the policy creator to inside of the console to do it, but you have to read the documentation. There are so many conditions in particular that you can set. But as far as the policy permissions themselves, there's only a few. In other words, if you want to see all of the actions and operations, there's only a limit, you know, a maximum of like 100 or something in there, right? That you can do, but you have to actually look at the documentation for that or use the policy creator. So whether you're using identity-based permissions, which are users basically having policies attached to them, or resource-based permissions is where you attach a policy to the service, both can grant permissions to services. Now, resource-based permissions, let me just say this again in case I missed it. S3, SQS, SNS, and OpsWorks are the only 4 services. Wait, is that right? S3, SNS, SQS, OpsWorks. Yeah, they're the only 4 services that support resource-based permissions. That's it. The rest of it is all identity-based permissions. Has a general rule of thumb. Everything that we just talked about is all about identity-based permissions. So I'm letting you know that resource-based permissions exist because there are rare exceptions, like with S3 in particular, where you have to use resource-based permissions in order to let everyone access an S3 bucket. So no groups, no roles can work with resource-based permissions. You can only assign user principals. Although I say that, I have seen people put groups and roles inside, but you cannot create groups and roles inside of resource-based permissions. They have to already be defined. Here's the difference, by the way. I keep going. Here's the singular difference between these 2 policies. If we're looking at this, just a note, notice that this has an effect, it has an action, and it has a resource. Now, conditions are optional, so there's no condition here, but there could be a condition. Notice that otherwise, this is identical, right? Now, if we look at the resource-based policy over here, there's a name for the policy. There's an effect, which this matches, right? Then there's an action, and then there's resources. And if we look at this, these all match. This all matches this. Effect matches effect. Action matches action. Resource matches resource. But guess what doesn't fit? There's no principal in the SID. So you have to say what users or principals can talk to this system. By the way, this could be, right? This like particular piece right here. This could be an account number. It could be a user, could be a group, could be a role. But notice that you can't create them here, right? You have to use IAM to create them, but the policy definitions are the same. So Billy, I guess to clarify, I think I said no at first. Maybe that was a little ambiguous. You actually can stick groups and roles inside of these principles. Okay.
I'm seeing differences like in styles of the code and the way it's laid out. It's just because of a possibly different language that you're using for both sides there, or I mean, why would it be so different?
Well, probably one of the differences is that you might notice that there's brackets here and here, right? And there's like brackets over here and brackets over here. That's because they're listing multiple variables, right? They're listing multiple parameters. So they're putting it into a list, right? So that's why. But I mean, it's all JSON. Does that make sense?
Yeah, I was mainly looking down from the action part. From action down, it's like very much different. But yeah, I mean, I guess it's a different system. I guess might be slightly different of the way it's called.
They're calling IAM over here. Over here, what they did is that instead of defining individual things, they just put a star in there, which basically says any API call for S3, right? They're going to allow against these buckets and this bucket contents. That's all. So the stylization, the syntax is all the same. It's just the number of parameters, right? And then which service they're calling.
Okay.
Yeah, because I mean, this should be all still double brackets, right? First bracket here, second bracket here. Yeah, so I think it's following standard JSON definition. All right, so we got identity-based policies that are attached to users, and we got resource-based policies attached to services. Now, Sometimes Amazon will write policies for you, so you don't have to write them, like read-only policies or full administrator access policies. They usually also sometimes have a power user policy. So it's like they've got read-only, power user, and then they've got like admin access. These are AWS like managed policies. It means AWS generates them and AWS updates them every time they add a service. Now, these are identity-based policies, and they can be attached to multiple users, groups, and roles, right? And these are all part of the managed system. Sometimes users will create customer managed policies, right? And they are created and managed by the users. So this is something important to know for the exam. You cannot modify AWS managed policies. You can use them, but you can't change them. If you want to modify a policy, you have to create a customer managed policy and make it yours. Now, can you copy an AWS managed policy, put it into a customer managed policy, and then make it yours? Of course you can. You can cut and paste if you want to, right? So, you can do versioning and rollback, central change management. You can delegate permissions to other users, right? That's easy. Inline policies are a little different because they are basically embedded into a user, into a group, or into a role, right? So it's like they're embedded into the user like space itself, whereas the managed policies are attached almost like an external entity. This is where you actually edit the permissions of the user directly and grant them explicit like permissions as part of being a user, part of being a group, or part of being a role. People typically, it's not recommended that you use inline policies because there is literally, you have to attach one per entity. You can't share a policy. If you grant somebody administrator access and you do an inline policy, it is literally inside the user. It's not a separate policy definition. So you can't centrally manage inline policies, which is why they say, don't really use them, right? Don't use an inline policy. Resource-based policies, by the way, are typically not recommended also because resource-based policies are, in a sense, inline-based policies. They are attached to the service in question, right? This is a one-to-one relationship between the service and the policy. So inline policies, both for identity and for resources, are generally not recommended. So hopefully that's pretty straightforward. Now, the evaluation logic, I mentioned this before. What's the use case for an inline policy? So inline is what they had first, Anthony. So if you have just a one-off special user, or mainly you've got services like S3, for example. So for example, if you want to make S3 publicly available to everybody, you have to attach a resource-based policy to it. Why? Historical reasons. That's just the way it was. S3, SNS, and SQS, and I didn't know OpsWorks did this, but it does. They all predate the existence of IAM. In other words, there were no users and groups inside of AWS until like 2010. I think that's when IAM came out, if I remember correctly. I wasn't working heavily with AWS until November 2011. My point being is that since they predate IAM, the way people got those to work is they used resource-based policies instead of identity-based policies. That's why those services still have resource-based policies. Amazon's retired 15 other services that also had resource-based policies. But what happened is that SNS, SQS, and S3 all can be made publicly available to anybody on the internet. You can't do that with identity-based policies because then who's the identity? But with resource-based policies, you can say, look, I'm open to the world, right? And it just seems to be some kind of stricture or restriction around the AWS permissioning system. But resource-based policies are used to grant other accounts or the public access to your services. You may note that, like, I don't know if anyone reads Last Week in AWS by Corey Quinn. If you don't, by the way, I highly recommend you do. It's a very snarky and entertaining way to stay up on AWS information. But he publishes every week people who publish all their information from S3, like PII, like credit cards and whatnot. And those are people who usually have resource-based policies that allow the world to read their buckets, and they haven't restricted access to it. So So general inline policies are mainly now for services. You don't really use them for users, groups, and roles explicitly. Main use case, you got to make it publicly available. One of the labs today, by the way, is for S3. I think it's going to let you set up a static website. I think that's right. Or was that 4.0? I think it's still in 3. So you're going to see what they call a bucket policy or a resource-based policy. Okay, so when it comes to evaluation logic, remember I said that if you explicitly deny someone access, they will never get access to the resource. If there isn't an explicit deny and there's an allow, then that person will be allowed. If there is not an explicit allow, then what will happen is the person will automatically be denied. Best practice, apply policies to groups, follow the principle of least privilege, and in general, don't worry, because if no one has permissions, then no one can get to your system. It's a little bit like launching an EC2 virtual machine inside of AWS. By default, the firewall is not going to allow anybody to see that virtual machine, even if it's on the internet. So here, by the way, is a policy where it's basically saying we're going to allow access to any API call in S3 or DynamoDB as long as it is the polynotes table or the polynotes web bucket or the polynotes web bucket, sorry, polynotes MP3 bucket contents. Now, the one below is a little weird because it basically says, well, you can't do anything to any other resource unless it's polynotes or polynotes web or polynotes MP3. So the one below is a little weird because it says basically you're denied from touching any other table or any other S3 bucket unless it's the buckets in question. I just want you to know, people don't do this. I don't know why they show this example, because you don't need to explicitly deny someone access to other tables and buckets unless you're concerned that there's some rogue administrator in there giving you access to stuff. Because by default, you're denied access to any resource unless you're explicitly allowed access to the resource. So the second statement, the deny statement, is going to cause a ton of problems if another administrator comes in and tries to grant access to another thing to that user, because that second statement is going to block the user from accessing any other table or S3 bucket except for the ones in blue or red below. So, but I mean, this is a way that the allow and deny works, right? Notice here that we're giving user access to a specific table, specific buckets, and then, you know, it's like, why would you use the second statement, right? This ensures they can't use any other resource. If you have tight security requirements like this, I could see you doing this. But I gotta tell you, in most corporations, they don't do this. They just are explicit about what they grant access to. If they're super concerned because they've got too many cooks in the kitchen, hope you know what that phrase is. It's just, there's too many administrators into the account, then they might do this in order to restrict access, right? And remember that if you deny someone access to something, they can never access anything until that deny is removed. Indeed, Adam, no one does want to pull a capital one. Who wants to be that guy? Okay. Other questions are IAM user accounts are needed? What if a user needs like special privileges? Let me ask you this. What if there's an auditor in another account who needs to get access to 50 other AWS accounts? Does that auditor now need a username and password for the other 50 accounts? The answer is no. What you can do is that you can just give that person a role, give them permission to assume the role in each of the 50 accounts, maybe give them read-only access, and now they can just switch from their user in that other account and assume the roles in the other accounts as needed in order to do auditing. This is true if the identity exists in AWS, but outside, or if it's a mobile app, for example, you might just give it a role, meaning once it authenticates with Cognito, for example, or Google or Facebook, you then might give it a role so it can actually do something inside of AWS. Remember, roles are really for authorization, for granting someone permissions. They're not for proving that the user is who they say they are, right? That's authentication. So this is what a role is really for. Is a role is used to grant a user who's already been authenticated permissions. Now, who did they authenticate with? Well, did they authenticate with Google, Facebook, Active Directory, Okta, Ping Federated, AWS? It doesn't matter who they authenticated with as long as AWS trusts the entity that did the authentication. If your AWS account does not trust the entity who did the authentication, it cannot give it a role. Make sure that's super clear. Your AWS account has to have a trust relationship with any identity that you want to use for authentication that is outside of AWS. That could be Google, by the way, could be Facebook. You could trust their authentication methods. You could trust Active Directory if you want to authenticate outside of Active Directory. You could trust, like I said, any identity broker as long as it has a trust relationship with AWS. Now, I mean specifically your account, not just with AWS, the company. Your account has to have the trust relationship. If a user is assigned to multiple roles, one with an implicit note, what happens? Billy, you can only assume one role at a time. So whichever role is active is the one that takes precedence. You can't assume two roles at the same time. Remember, it's like putting on a Batman suit. You're not going to put on a Superman suit and a Batman suit at the same time. You got to pick one or the other, right? That sounded weird, but yeah, I think you get the idea, right? Yeah. I mean, seriously. Wasn't there a comic book where like Batman ended up with like Superman's powers or something? That was a nightmare. Anyway, moving on. Not that he's a bad guy, but just because, imagine being that smart and having Superman's powers. It's ridiculous. Any other questions about this? Because like this whole user groups and roles concept and the identity policies versus the resource-based policies, it can be complicated, especially if it's the first time, right? Yeah. Being a billionaire probably helped me be a superhero, I'm just saying. Do role policies supersede user policies? So Austin, that's a good question. So if you're a user with a certain amount of permissions, when you take on the role, you take on that role's authorization identity. So you become that role's like policies, if that makes any sense. So you're no longer, from a security perspective, your user policies, you're now your role policies, because you've actually changed identity in a way, right? So the role policy is what you become. So like most of us aren't going to roll into it, no pun intended, roll into a more restricted role. We usually go into a role that gives us more permissions. But yeah, just so you know. So your user like permissions go away, you take on the role permissions. When you come out of the role, you go back to your user permissions.
But then isn't a user a type of role?
No, because you can't log in as a role. Don't get me wrong, the user has a role, like a security role, but it's part of the authentication mechanism plus the authorization mechanism, right? That's the difference with a user. Is a user has an authentication piece as well as an authorization piece because of the policy. A role only has an authorization piece. Now, I know this is going to sound weird, but we're going to talk about authentication and authorization even more because I know you're like, man, that was such an exciting and deep topic. Let's go deeper, Forrester, because I really want to talk about this. I don't want to talk about Harry Potter and superheroes. Let's move on. Okay. So, hold on one second. Oh, yeah. Okay, so this just talks about the different ways in which you can identify yourself. And this is significant, right? Because I mentioned this earlier in that IAM is used for you to authenticate and authorize for AWS access. What did I say you had to use if you wanted to log in to an operating system? Does anyone remember what I said you had to use in order to get access to an operating system? Because it wasn't IAM. Yeah, Gerald, a key pair, right? A key, Andrew, that's perfect. The reason is, by the way, is that the operating system has its own mechanism for authentication and authorization, right? A database, if you've ever logged into the database with a username and password using like an SQL workbench or whatever, that's a different username and password, right? If you log into Google, that's a different username and password than what you use for Facebook, right? So that authentication and authorization mechanisms, they're all different depending on what context you're signing into. If you sign into Kubernetes, for example, Kubernetes has its own mechanism for authorization and authentication. So there's a bunch of different ways to approach this, but here's what you need to kind of like summarize. I said this very clearly earlier. I'm going to say this again because this invariably comes up as a question on the quiz, on the certification. When you want to log into the website, that's the management console. That's a username and password. Every single thing else is going to be an access key or a secret key. That's it. CLIs, SDKs, you want to query an API raw, right? You want to run the CDK, you want to, right? That's all going to require an access key and secret key if you're not logging into the website. The website, the management console is the only thing that has a username and password. If you want to log into an EC2 instance, that's a key pair, which we just mentioned. If you want to log into a database, that's a username and password for the database. Those are different systems. Kubernetes has its own certificate system for managing users. You can hook up your database into AWS. You can hook your EC2 instance into AWS. You can hook Kubernetes into AWS. Then you can use your IAM username and password to log into those systems. But that's not what they do by default. They don't do that by default. You have to set that up. It's either a checkbox or like with Kubernetes, it's like a 10-step process, but it's not hard. You just need to do it. Okay. I want you to notice that little statement at the bottom. MFA for the win, right? We want you to use MFA. Actually, pardon me just 1 second. I just need to check on something. Just something that occurred to me. Yeah, you know what? Sorry. That's what happened. Bear with me just 1 second. Bear with me 1 second, because I wanted to make sure that your labs were ready to go. And I realized that there was an error earlier, and I just want to check and see if it was still going, and it is. Looks like it's still having a problem. So I have to shift gears here in a second. All right, there we go. Perfect. That just got fixed. Yay. Okay, good. Hopefully that'll make a smoother. Let's see, Gerald. So you want to know how the key pairs are created? So here's an example. Let's say that we're in EC2, and it probably will default to Ohio. So I need to make sure I'm in Oregon. All right, Oregon. So notice that here, I haven't done a whole lot in Oregon, although there's an instance here. And the reason there's an instance here is that it's a Cloud9 instance because I started a Cloud9 environment. Notice that right now the instance is stopped. If I wanted to get access to this, when I launched it, I needed to have a key pair associated with it. Key pairs are in EC2, and you can actually come down here and click on key pairs. And notice I don't have a key pair. If I click on create key pair, it's going to ask me for a key pair name, which I know that sounds weird, but that's usually what I do. What is today? 1/24. I've been kind of upgrading to 255.19 because it seems to be a more secure algorithm. But if you do RSA, you can actually choose either the PIM or the PPK format. Just know that PIM is for use with SSH, and then if you're using PuTTY, you have to use the PPK format. Be aware that you can convert the PIM format into PPK if you need to. So, you know, there's a Putty has a converter, although Putty's pretty old, actually. I wonder if there's better tools. So you click on create key pair, and then notice what it's doing is that it's going to give me the private key. The private key is the actual key. The public key, which is actually listed inside of AWS, think of that as the lock. That's not actually how it works, but it's like easy to think of it that way. You're going to put the lock everywhere you want to log into, but you're not going to share the key with anybody. Key is yours. The private key, you should keep to yourself. The public key, which I also prefer to call the actual lock, I'll stick that everywhere. Now, don't get me wrong, they can both be used to reverse decrypt to each other. But you're going to save that PIM file. And so when you SSH, you're actually going to use that PIM file. You're going to call the PIM file as part of your login process to make sure that you can log into the system. So any EC2 instance that I launch, if I go and launch an EC2 instance, let's say I just go to launch one, which this might be interesting to see. I'm going to select it. Let's just go with the T2 micro because it's free tier eligible. Let's say I want to review and launch because I don't really care about anything else. And ooh, that's going to hurt. Hold on. Let me edit that security group really quick. Don't usually open those up to the world, just so you know. And let's say I want to launch this. The first thing it's going to ask me, Gerald, is going to ask me, hey, what key pair are you going to use? Because if I don't put a key pair on this system and I'm not running the SSM agent on there, which is the systems manager agent, I won't be able to log into it, right? So notice that the US West 2 key is listed here because it's the only key I have. If I had 50 keys, they would all be listed here. I can also proceed without a key pair, but it's going to say, hey, by the way, you can't log in if you don't have a key pair unless you use SSM. And by the way, you can create a new key pair if you want to, but I'm just going to choose an existing key pair. And then what would happen is I would just click on launch instance and this would launch the machine. And then I could log into that machine with the key pair. I could launch 50 boxes, by the way, 1,000 boxes with that key. Because the public key is what Amazon has. I have the private key. They can replicate the public key all day long, but only one person or entity, ideally, would have the private key. That would be me. So Gerald, I hope that helps.
Yeah, great. So then how are the other private security keys created that you're speaking about? So this is to log into the box, the key pair. Then we have these secret keys and secret access keys and so forth.
Oh, yeah.
Other stuff.
Yeah, so the other keys are all created underneath IAM. So that was EC2. So if I go to my user, Spartan Sage, if you click on security credentials, this is where you create the other keys. This is what we were looking at earlier. You can only have 2 active keys per user at a time, but I can create access keys here. But the way I get around that, by the way, is I actually create users for my laptop. I used to have other machines here, but COVID has not been kind to my boxes, just to be frank about it. So the only thing I have left is my primary desktop and my laptop. That's it, right? So, oh, actually in a Jenkins server, there's a Jenkins server floating around, right? But this is where you create it. So under the user ID, under IAM is where you create all the rest of the security credentials. Good, horrible, more questions?
Yeah, this part still hasn't sunk in fully yet for me. I mean, I understand that. So basically, I'm understanding that there are 2 places to go and create these keys. For the key pair, there's a separate section. You're going to create a key pair to launch a box and to log into that box. Then under the IAM, there's another section. You go to create these secret keys for you to, I guess, do things, other things in the boxes. So yeah, it hasn't quite clicked yet, but I guess with more material and personal review, I guess.
Well, in the lab, we'll clarify it. Let me make sure I make this statement really clear. The EC2 key pairs under EC2 are only used to log into systems.
Oh, they're on the EC2s only.
Yeah, so if you want to log into an EC2 box, you have to use an EC2 key pair or another mechanism. These keys right here, these access keys, are only used when I'm on a system outside of AWS primarily, and I want to manipulate AWS infrastructure. So these access keys here are used to programmatically interact with my account.
Okay, I see.
So 2 very different systems, right?
Yeah. Okay.
Yeah. Yeah. And then if I add another system, like a database system, that has its own username and password to it. That is not even governed by AWS at all. AWS doesn't control that, because if you start an MS SQL box or an Oracle system or a Postgres, when you start it up, you have to create like a primary database username and password. That's a whole different system. So every time you create a new application, if it has its own user data store, you have to like put a user in there. This is why people don't like using infrastructure as a service, because there's too much to manage. If this was all SaaS, then you just use it and go. You don't. IAM controls everything at a SaaS level.
Okay.
So that's another like key distinction. At an infrastructure as a service level, you are creating distinct systems that have their own username and passwords. At a SaaS level, everything is managed by IAM. So you don't have to have a separate username and password for any of the SaaS services for AWS. Hopefully that helps.
Yeah, it did. Thanks.
If that's not clear, by the way, by the end of the lab, please let me know, because we will definitely go after that again. Okay. Management console, you've already seen, right? Command line, you've already seen. You haven't seen API access with a code yet, but don't worry, it's coming. I promise you. For those of you who are like, man, I just really haven't been slapped in the face by Python today, it's coming. You'll get a chance, right? I'm just kidding. Coding is fun. Notice here that I already mentioned the .aws file with the credentials in it. Notice that, you know, there's different profiles underneath that file. You're going to have an access key and a secret key defined at least once in that credentials file. When we were looking at it earlier on my system, we were in the .aws directory, right? Oops. And if we look at config, wait, do I even have a more? Oh, no, I don't have a more. That's right. I forgot. But I do have a cat. So there's all these profiles in here. This is just configuration information, because this is the config file. If I were to cat my credentials file, which I'm not going to do because it's going to record and show my keys, which I do not want to replace right now, right? It's going to look like this.
Sure.
Right? It's going to be default. It's going to say AWS underscore access underscore key underscore ID. And that's going to have a large alphanumeric next to it. So just know you can create multiple profiles, which, by the way, you can call those profiles on the command line if you want to, but you have to have the default profile, because that's what it's going to use by default when you don't specify a profile, which is pretty much what you do all the time. Where do you get these access keys from? Just a reminder, you get them from IAM underneath the user, and you have the access key section under the security credentials. This is where you get it from. See the PBOH? If we come back to the command line and run AWS configure, it shows that PBOH is listed there because that's the key I have inside my credentials file. All right, so again, this is for programmatic access outside of AWS. So this is on my laptop, this is on my desktop, this is whatever. Is that these are what these access keys are for, so I can interact with AWS without having to log in every single time. Funny thing, really different from Azure, by the way, because you type in AZ login on the command line, it pops up a browser, you log in, and then it gives credentials back to AZ login. You can shift that behavior, but I like, this is a little bit more interactive. I kind of like it, actually. As a general bottom line, you know, try to use the credentials file. Do not stick any kind of secrets or login information in your code, especially if it's going to get checked into repo. That is a huge no-no. If you check that into GitHub, by the way, Amazon usually finds it somewhere between like 60 seconds to 10 minutes, and then they will lock that credential inside your account. So just know that if you post a gist that has your AWS secret or access key into it, and you can test it out if you want to, they usually find it within about like somewhere between 1 to 10 minutes, and they'll lock that file down. They will disable that key and ask you to check your account because, you know, someone probably hacked it, because people are just scanning constantly for these secret keys to your AWS account. Just know that on the command line and on the SDK, you can actually switch roles if you want to. Kind of beyond the scope of this. That's an advanced developing on AWS, but still, you can do it. Do not use root credentials. Do not stick your credentials in code. Do not put them on gists and other things. Just kind of save yourself the headache. Just remember that everything is in your home directory under .aws, and that's true whether it's Mac, Linux, or Windows. It's all under .aws, okay? By default, your application first is, if you've specified your credentials or region in code, it's going to read the code first. If you haven't done that, it's going to look for an environment variable in the execution environment. If you haven't done that, it's going to try and read your credentials file in your .aws directory in your home. If it's not there, then it's going to look at your instance role and try to derive security information from the environment that it's sitting in using what's called the EC2 metadata. That's data about the virtual machine. This sometimes shows up on the exam where they're like, hey, you just added a role to one of your EC2 instances where you have an application running, but it still doesn't have permissions. And the answer is for you to go in and delete the .aws directory because you left information in there about your security permissions. And so the application is using that instead of using the role. Because in terms of priority order, hard-coded first, environment variables, .aws directory, and then EC2 instance metadata. So you might want to remember that. Now, here's an interesting statement. So request AWS services have to be signed. It's not negotiable. That means they must contain information that authenticates the requester, right? They're usually signed by using the access key and the secret access key of an account. So signing is required because it's going to protect the data in transit. It's going to protect against replay attacks. It's going to, right? It is, by the way, by default going to use TLS, SSL, right? So you do not need to explicitly sign your request if you're using the CLI or the SDKs. If you decide to write your own call to AWS because you don't like easy, I'm just kidding. Maybe you have a security reason. I don't know, right? Then you're going to have to basically write your own using the HTTP authorization header. You're going to have to add a query string value to the request, right? And just know it probably is easier to use an SDK. Amazon has a doc on how to sign AWS API requests if you want to write your own, okay? Just FYI. Do note that if you get an access denied, right, you got to make sure you verify your permissions, whether it's identity-based policies or resource-based policies. You just have to verify, okay? Also, by the way, it could be a conditions problem. You might think you're on VPN, so you're making a call, you're getting it denied, and then you realize you're not on VPN, so you need to be on VPN to make that happen. So then you just need to log into VPN to make it happen, okay? Especially with booze, I think most of your API calls have to run through your corporate network. So, little things like that can really throw you off. I've been gone to my parents' house, for example, and went to log in. It was like, oh wait, I'm not at home anymore. I just VPN into my house and just go from there. Okay, question for you. Name one of the 4 services that has resource-based policies. Sweet, you got 3 out of the 4, and there's the 4th one. Perfect, good. OpsWorks, by the way, for people of those not familiar, because I don't think we're going to talk about that service in this. OpsWorks is if you want Chef or Puppet, you want a configuration management server, that's what OpsWorks does. OpsWorks is basically there's an AWS proprietary one, There's a chef emulator and a puppet emulator. So just know that that's a configuration management service. Most people don't use resource-based policies on it, just FYI. All right, other questions. What is the one thing other than a SID that's in a resource-based policy that is not inside of an identity-based policy? So not the effect, not the action, not the condition, not the resource. What is the one thing that is inside of a resource-based policy that is not inside of a identity-based policy? There's a name for it. What do we call users, groups, and roles? Those are collectively known as, good, Jacob, principles. Good, Justin, I see it. Principles, right? So principles are defined in resource-based policies because those are attached to services. Identity-based policies don't need to define the principle because the policy is attached to the principle, right? Good. Okay, let's do this one then. All right, so a user with an access key and secret access key can sign into the AWS management console. Is that true or false? That's right. It's false, right? Because you need a username and password as stated, right? Good. All right. A newly created IAM user can sign in to the AWS management console by default. By default. Is that true or is that false? Yeah, remember AWS is like really first and foremost a security company. So by default, you don't get to do anything. All right, true or false? Customers cannot edit AWS managed policies. Is that true or false? Man, they're doing a good job of like asking questions that are actually on the exam. Kind of shocks me a little bit. I didn't think they ever read my emails. All right, cool. Customers cannot edit AWS managed policies. They changed this the last time since I taught it about 2 months ago. True, right? So it's true. You can't edit AWS managed policies, but you can edit customer managed policies because you're the customer. The most secure location to store credentials is in a properties file with the code in the code base, publicly posted into a public GitHub repo. Is that true or false? I hope my added color like helped shape your answer. So that's false, right? If you really want to be an MVP, just post that publicly on GitHub on a gist. It's totally fine. An IAM user account is required to access AWS resources. This one's a little tricky. Notice it doesn't say manage AWS resources. It says access AWS resources. Can you imagine if you needed an IAM user to access a web server? I'll be frank. Forgive my vernacular here, but that would suck, honestly. So you have to create a user for like how would anonymous users ever get access to your resources? So that's false, right? Okay, last one. An IAM user account is automatically created for the root user. Is that true? Is a root user the same as an IAM user? So true statement. The root user is the only user that's created for you by default. Every other user you have to create. Cool. All right. Questions? Okay. Okay, let's talk about the lab and then we're gonna do the lab. So we're gonna talk about the lab, we're gonna do the lab, and then we're gonna talk about what we did, because you know that's how we roll now. So if anyone has any questions about anything IAM, please ask. Now is the time.